Advanced overlapping sets problems. E and F are counted twice and section G thrice. Hence, we need to subtract sections D, E, and F once to count section G only once and subtract section G twice, again to count section G only once. When we subtract sum of exactly two group overlaps from A plus B plus C, we subtract sections D, E, and F once. And next we need to subtract only section G twice. That's it. Let us look at an example. Workers are grouped by their areas of expertise and are placed on at least one team. 20 are on the marketing team, 30 are on the sales team, and 40 are on the vision team. 5 workers are on both the marketing and sales team. 6 workers are on both the sales and vision teams. 9 workers are on both the marketing and vision teams, and 4 workers are on all three teams. How many workers are there in total? First, translating this problem, we get are placed on at least one team. So members of none is equal to 0. 20 are on the marketing team, which is M is equal to 20. 30 are on the sales team, S is equal to 30. 40 are on the vision team, V is equal to 40. 5 workers are on both the marketing and sales teams. MNS is equal to 5. Note here that some from these 5 can be the members of vision team as well. MNS is sections D and G on the diagram. Assuming marketing is equal to A, sales is equal to B, and vision is equal to C. 6 workers are on both the sales and vision teams. S and V is equal to 6, the same as above sections F and G. 9 workers are on both the marketing and vision teams, which is M and V is equal to 9. 4 workers are on all three teams, which gives us Mn, S and V is equal to 4, which is section 4. Now to find the total, applying first formula, as we have intersections of two groups and not the number of only two group members, the total is equal to M plus S plus V minus of MNS plus MNB plus SNV plus MNSNV plus neither, which gives 20 plus 30 plus 40 minus of 5 plus 6 plus 9 plus 4 plus 0, which is equal to 74. Therefore, the answer is 74. Let us consider another question. In a consumer survey, 85% of those surveyed liked at least one of the three products 1, 2, and 3. 50% of those asked liked product 1, 30% liked product 2, and 20% liked product 3. If 5% of the people in the survey liked all three of the products, what percentage of the survey participants liked more than one of the three products? So translating this, we get 85% of those surveyed liked at least one of three products 1, 2, and 3, which means total is equal to 100%. Also, since 85% of those surveyed liked at least one of three products, then 15% liked none of three products. Thus, none is equal to 15%. 5% of the people in the survey liked all three of the products. So A and B and C is equal to G is equal to 5%. The question is, what percentage of the survey participants like more than one of the three products? You apply the second formula. The total would be like product 1 plus like product 2 plus like product 3 minus liked exactly 2 products minus 2 into liked exactly 3 products plus liked none of the 3 products. So it would be 100 is equal to 50 plus 30 plus 20 minus x minus 2 into 5 plus 15, which would be x is equal to 5%. So 5% liked exactly 2 products. More than one product liked those who liked exactly 2 products. 5% plus those who liked exactly 3 products. 5%. So 5 plus 5 is equal to 10% liked more than one product. So the answer is 10%. Next question. A student has decided to take GMAT and TOEFL examinations for which he has allocated a certain number of days for preparation. On any given day, he does not prepare for both GMAT and TOEFL. How many days did he allocate for the preparation? He did not prepare for GMAT on 10 days and for TOEFL on 12 days. He prepared for either GMAT or TOEFL on 14 days. We have total is equal to GMAT plus TOEFL minus both plus neither. Since we are told that on any given day, he does not prepare for both GMAT and TOEFL, then both is equal to 0. So total is equal to GMAT plus TOEFL plus neither. We find total. He did not prepare for GMAT on 10 days and for TOEFL on 12 days, which is total minus GMAT is equal to 10 and total minus TOEFL is equal to 12. This is not sufficient. He prepared for either GMAT or TOEFL on 14 days. So GMAT plus TOEFL is equal to 14. This is not sufficient. So 1 plus 2, we have 3 linear equations. Total minus GMAT is equal to 10. Total minus TOEFL is equal to 12. And GMAT plus TOEFL is equal to 14. So we have 3 linear equations with 3 unknowns. Unknowns are total, GMAT and TOEFL. So we can solve for all of them. So this is sufficient. Just to illustrate, solving gives total is equal to 18. He allocates total of 18 days for the preparation. GMAT is equal to 8. He prepared for the GMAT on 8 days. Total is equal to 6. He prepared for the TOEFL for 6 days. Neither is equal to 4. He prepared for neither of them on 4 days. So the answer would be C. Let's look at the disguise 3 overlapping sets problem. 3 people each took 5 tests. If the ranges of their scores in the 5 practice tests were 17, 28 and 35, what is the minimum possible range in scores of the 3 test takers? Consider this problem to be an overlapping sets problem. So number of people in group A is 17. Number of people in group B is 28. And number of people in group C is 35. What is the minimum number of total people possible in all 3 groups? Clearly, if 2 smaller groups A and B are subsets of bigger group C, so if all people who are in A are also in C and all people who are in B are also in C, then total number of people in all 3 groups will be 35. Minimum number of total people cannot possibly be less than 35 since there are already 35 people in group C. Notice that maximum range for the original question is not limited when the maximum number of people in all 3 groups for revised question is 17 plus 28 plus 35. In case there is zero overlap between the three groups.